All right, what we're discussing today is the concept of period and frequency. And again, the math in this section isn't difficult at all, but what I want to make sure you understand is the concepts of period and frequency. Period is how long it takes for an object in uniform circular motion to complete an entire circle. So if you think about the period of the Earth around the sun, granted it's not quite a circular orbit, but for the purposes of this class, it's pretty close. So it's going to take 365.24 days for the Earth to go one time around the sun. So that is its period. If you think about how long it takes the moon to make a complete orbit around the Earth, that takes, I don't remember the exact number, it takes approximately 28 days for the moon to go all the way around the Earth one time. So that is its period. The frequency is how many times in 1 second the object will go through a full circle. So if you're talking about something that's going around really quickly, so if it goes zhoo, 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 really quick, it has to make that noise at the same time. So maybe it goes around the circle 3 times in a second, and so that would be its frequency. Frequency and period are reciprocals of one another, and so if the period is in seconds, so the time to complete a full circle, since we're talking about time, we normally express that in seconds. You can express it in days or months or years or weeks or whatever else you want to. If we're going to plug it into some of our other equations, we're going to have to put it into seconds to match the units that are in newtons and that type of thing. If I want the frequency, all I'm going to do is take the reciprocal of the period. So if I have 1/seconds, that is a unit known as the hertz, and I usually abbreviate it with an HZ. So it's per second. So it's how many cycles per second. So 3 hertz, if it goes around the circle 3 times in a second, then the frequency is 3 per second or 3 hertz. So let's look at example 7.5. And again, not because the math is difficult, but because I want to make sure you understand the concepts. He says a hyperactive dog is running in a circle, and the circle has a circumference of 2.2 meters, and the dog runs at a constant rate of 1.6 meters per second. We want to know what the period and the frequency are. So circumference of 2.2 meters, speed of 1.6 meters per second. So if I look at that, I'm basically going to say, I know that in algebra, sometimes you talk about how the distance is equal to the rate times the time. That's not unlike some of the formulas that we saw earlier in the semester, where I had velocity equals displacement over time, or speed equals the distance over time. I think this was actually an X when we learned it. So basically this is the same thing. The rate times the time is going to equal the distance. So this is just a rearrangement of these same types of equations that we have already learned. I'm just kind of generalizing it into a distance equals rate times time equation. Okay, so what is the distance that the dog travels to get in a full circle? It's going to be 2.2 meters because that's the circumference of the circle. So it's going to be 2.2 meters. I know that his rate is 1.6 meters per second. So that will go here. And then I can solve it for the time, which in this case is going to be also the period. So if I divide that out, that's going to give me 1.4 seconds. Meters cancels, and I'm left with seconds. So what that tells me, the period of 1.4 seconds tells me it takes the dog 1.4 seconds to go around the circle one time. So that's the period. Now, if I want to know the frequency is just the reciprocal of the period. So therefore, I'm just going to take 1 over 1.4 seconds. And if you divide 1 by 1.4, you're going to get 0.71 per second, or 0.71 hertz. Now, what does that mean? What it means is that the dog makes it almost 3/4 of the way around the circle in 1 second. He doesn't get all the way around the circle in a second. He gets 0.71 hundredths or 71 hundredths of the way around the circle. So again, about 3/4 of the way around the circle in a second. So this tells me how long it takes to travel the whole circle. This tells me how much of a circle he gets in a second, or if the number were larger, it would be how many times he gets around the circle in a second. So that's the difference between period and frequency. Make sure you remember, and with your level of math, I'm sure it won't be a problem. Sometimes they will give you the radius of the circle, and you may have to calculate circumference. So just remember that circumference is 2 pi times the radius, in case you ever have to calculate what the circumference is in the problems that you're going to be working.